Chapter 2, Part 2, we are going to start looking at growth factors. In number 16, we have the graph here. It shows a line for a tile pattern. We want to find out what is the growth factor for this line. That is, how many tiles are added each time the figure number is increased by 1. Explain how you found your answer. So we are looking at our picture, and we want to see what's going on. So we are told that every time the figure number goes over 3, it's going to increase by the number of tiles by 27. So we want to figure out what is the growth factor of just by 1. So instead of going over 3, what if we go over 1? So we are going to take a look at the change in y and the change in x. So change in y, delta y, is going to be how much we're increasing with our y values, which was a 27. Our delta x, which is change in x, is going to be 3. So every 3 units we go over with the x, we're going to go up 27. So if we simplify this, this is going to give us 9. So the growth factor is going to be 9. So growth factor is 9. So each time 9 tiles are added. So each time 9 tiles are added. In number 17, we want to find the output for the relation with the given input. If there's no possible output for the given input, we want to explain why. So we're going to plug 1 in for x. So we have 2 places. So f of 1 is equal to 1 over 1 minus 1, which is 1 over 0. This is undefined. We can never divide by a 0. So it is undefined. I'm just going to make a note. Can't divide by 0. In number 18, slope is a measure of steepness of a line. So this is something that you may have heard prior to coming to this class. It is the ratio, so that means fraction, of the vertical distance to the horizontal distance of a sloped triangle. So the vertical part of the triangle is called delta y, or change in y, while the horizontal part of the triangle is called delta x, or change in x. Note that that little triangle, that is delta. It's a Greek letter, and it's often used to represent a distance or a change. So for 18, what is the vertical distance, change in y, for this sloped triangle? So we are looking right here. We want to see how many units is it increasing. So that's going to be a 2. So I'm going to say delta y equals 2. What is the horizontal distance, or the change in x, for the sloped triangle? So if I look at the bottom, that's going to be 4. So delta x is 4. And I'm just counting the blocks over. So how could we use change in y and change in x to find the slope of this triangle? So because slope is change of y over change of x, if we put it together, 2 over 4, it's going to give us a slope of 1/2. So, and we can check it. If we go up 1 over 2, we have a point on the graph. Up 1 over 2, we have another point on our graph. The next part of this problem, we want to find the equation. So we know that we have a growth factor of 1/2. So we have y equals 1/2 x. And then we want to find the starting value, which is that y-intercept, which is going to be at positive 2. So y equals 1/2 x plus 2. In number 19, we're going to examine the line graphed at right with slope triangles A, B, and C. So first we're going to find the slope using slope triangle A. So I can see that we have a change in y of 6 here and a change in y of 4. So our slope for A, change in y over change in x, is 6 over 4, which we can reduce to 3 over 2. It's always a good idea to keep the slope as a fraction, because it's easier to go up 3 over 2 instead of going up 1.5 units over 1. Next, we're going to find the slope triangle of B. So we are increasing the y value by 3. So change in y is 3. The change in x is 2, so that's going to be 3 over 2. That's going to be the same slope. So what do we notice? They are equal. They are equal. So if we look at this line in number 19, it has a slope of 3 over 2. So every time we're going to go up 3 for the y value and over 2 for the x. So if we look at our triangle, the top triangle, triangle C, we know that the bottom is 3. We don't know what the change in y is going to be. So I'm going to set up a proportion over here and say that we know the change in y is going to be over 3 is equal to the change in y of the slope of the line, which is 3, over the change in x, which is 2. And now we're going to cross multiply. So 2 times the change in y is equal to 9. So we'll divide both sides by 2. So the change in y is going to be 4.5, or you could leave it as 9 over 2. So, and we could check. 4.5 divided by 3 is going to give us 3 divided by 2, or 1.5 as the decimal. The last part of this question says to draw a slope triangle on the line with a horizontal distance change of x of 1 unit. We want to find the vertical distance change in y of this new triangle. What do you notice? So right here, I know there's a lot going on. I did a slope triangle with a change in x of 1. So I noticed that my change in y is going to be around 1.5. And this also matches our slope. So if we take change in y over change in x and say 1.5 over 1, that's the same thing as our slope, which is 3/2, or 1.5. Number 20, we're going to draw a line with the change of y of 0, and we want to describe this line. So looking at my graph, and it doesn't matter where we put this, I'm going to have a change in y of 0, so I'm going to plot 2 points. So here, so if we say the change in y is 0, that means we're not going to go up or down, so I'm going to have another point right next to it. So this line is going to be horizontal. So this line is horizontal. The slope is going to be 0. So we now want to draw a line with a change of x of 0. So on my graph, I'm going to put a point somewhere. And we are told that the change in x is 0. So that means that we can go up and down, but we're not going to go over left or right. So this is now going to be a vertical line. So line is vertical. In number 21, Michaela was trying to find the slope of the line shown here at right, so she has selected 2 lattice points. Those are locations where the grid lines intersect. You will hear us talk about that in this class. And then she drew a slope triangle. Her teammate, Cynthia, believes that the change in y is 3 because the triangle is 3 units tall, while her other teammate, Essie, thinks that the change in y is -3 because the triangle is 3 units tall and the line is pointing downward. With whom do you agree and why? So if we take a look at this line, it is decreasing. So the slope is going to be negative. So we make a note, slope is negative. So if we take a look, we are going down 3 units, and then we will go over 4 units. So the slope is going to be -3 over 4. So the change in y is -3, the change in x is 4. So Essie is correct. So she's correct because the line is decreasing. When writing the slope of the line, Michaela noticed that Cynthia wrote -3 over 4 on her paper, while Essie wrote -3/4. She asked, are these ratios equal? Discuss with your team and answer the question. and then we want to find the equation of Michaela's line. So if we think about it, or plug it in your calculator, negative 3 divided by 4 is negative 0.75. If you plug in negative 3/4, you also get negative 0.75. So they are equal. It doesn't matter if the whole fraction is negative or just the numerator. They are equal. So our equation, if we go back and look at the starting value, it is 9. So y is going to be negative 3/4 x plus 9. Number 22, we are just going to find the slope of the line. So using our 2 points that are given and drawing a slope triangle, we are going up. Now we have to be careful because even though it looks like we're going by 1, which we are, the blocks, like the tiles and the tick marks, are not the same. So we are going to go over from negative 6 to 6. So we're going to go over 12 units. So the change in x is 12. And then our change in y, so we're going from 0 to 4. So it's going to be a 4, which we can reduce to 1/3. Number 23, one way to think about slope or growth triangles is stair steps on a line. Picture yourself climbing or descending the stairs from left to right. Each of the lines on the graph shown below at right. So of the lines A, B, and C, which is the steepest? So looking at the steps A, B, or C, hopefully you're going to say B. Which is the least steep? That would be C. Examine line B. What direction is it traveling from left to right? So D is going downwards from left to right. So it's going to go down, which means it's negative. So what number should be used for change in y to represent this direction? So if I pick one of these slope triangles, each of these is going down by 1, so it's going to be negative 2 would be my change in y. Because my page is cut off, I'm just going to continue writing on this page. So we want to label the sides of the slope triangle in each line, and then we want to find the slope of each line. So starting with line A, I'm just going to zoom in a little bit. We are going over 1, up 1. So our slope for line A, which I'll write down here, so line A is going to be 1. So 1 over 1, which is 1. Taking a look at line B, so I'm going over 1 and I'm going up 3. So my slope for line B is up 3 over 1, which is 3. Taking a look at line C, we're going over 2, up 1. So line C, so it's 1 over 2. And then line D, we saw is going down 2 and over 1, 2, 3, 4, 5. So down 2 over 5. How does the slope relate to the steepness of the graph? So the bigger the slope, the steeper the line, and the smaller the slope, the least steep the line is. So Cora answered part D with the statement, the steeper the line, the greater the slope number. Do you agree? If so, use lines A and D through A through D to support her statement. If not, change her statement to make it correct. So Cora is correct. But just be careful with the negative slopes. We are going to be taking their absolute value. All right, so number 24, what happens to the slope when the slope triangles are different sizes? For example, the line at right has 3 different slope triangles drawn as shown. Find the slope using each of the slope triangles. So we're going to focus on A first. So the change in y looks like we're going up by 1. And the change in x is going to go over 2. So our slope for A is going to be 1/2. For B, my change in y, I'm going from 2 to 5, so that's going to be 3. My change in x is going from 0 to 6, which can be reduced to 1/2. So far they are all the same. Triangle C, my change in y is going to be 2 units, so I'm going from 5 to 7. And my change in x, I'm going from 6 to 10, which is 4, which also reduces to 1/2. So we notice that they all three are equal. So the triangle labeled A is drawn above the line. Does the fact that it is above the line instead of below affect the slope of the line? So no, it doesn't affect it. So no, it doesn't. Draw another slope triangle for this line so that change in x is 1. What is the height, change of y, of this new slope triangle? So if we draw a slope triangle, let's say right here, and we go up, we can see that it is not exactly at 3. So it's kind of in between 2 and 3. So the change in y is kind of like, it's not a whole unit, so we're going to say it's a half of a unit when the change of x is 1. So if we take 1/2 divided by 1, that is going to be 1/2. No matter where the 2 points are on any line, that slope is, or on that line, the slope is going to be 1/2, no matter where those points are located, because it is that same line.